Okay, so for exponential and logarithmic functions, the question was about asymptotes. I've added in translations, domain, and range because those are also things that you guys have struggled with or mentioned weren't as easy as we had hoped. So looking at exponential functions, so the way that I remember these as far as vertical or horizontal, and this is not super mathy, but it's what works in my brain. So with an E and an L, exponential, it almost makes an H because we have the possibility of having an H. So that's going to be your horizontal asymptote. So horizontal asymptote for exponential. And horizontal lines are always y equals. So we know that our asymptote is going to be a y equals. And then for logarithmic, in my mind, this is an up and down, which means it's going to be your vertical. So a vertical asymptote. And it's going to be an x equals, because that's how all vertical asymptotes are. It's x equals. So speaking to your asymptotes, that's not super mathy or mathematically sound way, but that's how in my brain I keep the two separate so I don't get them confused. All right, so as far as transformations, because that is something that all of us have struggled with along the way and definitely in classes prior to you guys, you want to look at your parent function for an exponential. In this case, we added an a, which is going to change the vertical and horizontal compression, so the steepness of the graph or the lack thereof, and then your x minus h. So in the exponential part with the x is the h, and so that does its thing. And then we added a k as well on the outside, which can be added or subtracted. But your parent function, which would be where it started before we added all of that, for our exponential in this case would be y equals b to the x. So things we added were the h, the k, and the a. And each one will be in charge of moving something different. So like I said, a is going to be your steepness, your compressions, your stretches, all that fun stuff. H, which is one we really want to focus on, is going to be your left, right slides. So it controls the x value. H controls the x value. And then your k value is going to control the ups and downs. So k is going to be your up and down translation. So up versus down. So did the whole graph slide up or did the whole graph slide down? And then for your logarithmic function, your parent function, again, we added an a, there's an h, there's a k, is going to be y equals log base b in this case of x. And the b part can change depending on what you're looking at. The idea is whatever's in the basement is the base of the log, and it is your parent function details. I think is the right way maybe for that to make sense to you guys. Then from there, you're going to decide if it goes left, right, up, down, or all those good fun things, depending on how the equation's written. So looking at your asymptote, so y equals, that means it's going to be a horizontal asymptote. So the change is going to be whether it went up or down. And up, down is k. And then in your transformations for your log, it's the same thing. So k is still your up, down. And then h is still your left, right. And then, so in this case, with an x equals a vertical asymptote, that's changing how far left or how far right it can go. So it's going to be x equals h. So if you're just looking at the equation, if you find an h in a log format equation, then you're going to have x equals h as your vertical asymptote. If it happens to be an exponential function, you're going to be looking for that k value. If there isn't one, then it's going to be right there at the origin, just like if there's a lack thereof h value for your log function. But again, so exponential is horizontal, so y equals k, and a logarithmic is going to be vertical, which is going to be x equals h. So I'm going to use these guys, and we're going to skip over to asymptote because that's what we asked about first. So then after that, we'll go back, and if you want to hang out, stay in the video and check it out. So looking at an exponential, because it's 3 to the x power minus 2 means this is going to be an exponential function. So we know it's going to be a y equals. And if you had a worksheet like this, for me personally, to keep myself focused, I would do y equals and x equals all the way down. So log is going to be an x equals. Again, this is exponential, so it's going to be a y equals. Log is x equals. Exponential. E is a number. It is a button on your calculator, or if you're in Desmos, it is in the calculator there, but it is a number. So think of it kind of like pi. So it's an irrational number that goes on forever and ever, and it actually has a value. So it's not a variable. So we have another log, and log is an x equal. ln is also a log. It's a natural log. So that is also going to be an x equals. And then we have another exponential, which is going to be y equals. And then from here, we're going to go back and look for our k and our h values. So looking at the first one, y equals means y equals k, because it's going to be a horizontal asymptote. And so we're going to look for the k in this function. And that means not attached to the x, but out here. So that means minus 2. Looking at number 3, and I'm just going to go straight looking at my y's from a horizontal asymptote, so all my exponential functions first. So since there is nothing on the outside, it would have had to have been added or subtracted out here. This is an h value. It means it's going to be y equals 0. And then if we skip to our next y, again, so this is an h value, so we're looking for our k value. That's a positive 1. So y equals 1. Again, down to our next exponential is down here. Our positive 1 is going to be a negative 1h value, or our minus 3k value, because we have a horizontal asymptote. Now, looking at the log function, so we have an x equals h. H is the one that's going to be attached by parentheses with the x. So we have an h here. Now, it is x minus h in our format, like our outline up here at the top. So that means we actually plugged in a positive 3 here, because that's why it still looks like it is a minus the number. If it had been a negative 3, this would be x plus 3. Then here in our logs, there's nothing in here with that x, so it's going to be 0, because that 5 is a k value, so that's our up-down translation. And then for this log, it dropped down. Sorry, guys. Minus 4 is our k value. That's an up-down, not what we're looking for. We're looking for this guy, and it's x plus 2. Remember, the outline is a minus, so that means we put in a negative, because that double negative is what makes that translate into a positive. Last but not least, x minus 5, which means we put in a positive 5. So that's all your asymptotes, and hopefully that makes it make some sense just to see a couple in a row. Again, so log, you're looking at your h value as x equals h, and then exponential is y equals k value. And h and k is just the letters that we choose to use. Different formats, teachers, and programs may use a different letter, but the idea is the h is with the x, and the k is not. It's on the outside. So it's by addition or subtraction, non-related to where the x is. Now, for transformations or translations, so as things happen. So looking at this would be a base, like the parent function would be 3 to the x. There's nothing attached to the x, but there is that minus 2, which means it's going to go down 2. And then this guy, so this would be log base 4 of x as a parent function. That 3 is attached to the x, so that means it's going to be left, right. That's a positive 3, so that means it's going to go right 3. Because remember, x minus h is how that outline is written. Then for number 3, we're back to exponential. This is another h value because it's with the x, but it's a plus, which means a negative 4 was in there. So we're actually going to go left 4 because minus 4 was what was plugged in. The other way you can think about that is as if you solved it. It would be x equals negative 4, and that'll let you move to the left 4, that minus there. And then if I did x minus 3 equals 0, that would be an x equals positive 3, which is why it's right 3. This log, this plus 5 is attached to the end. So again, that's going to be an up 5. Nothing's attached to the x, and these are just like starters. There's ones of each, one translation. Now we're looking at this exponential function. E again is a number, but I have x minus 3. So that's my h value. So that's my left, right. It is minus 3. So that means it's going to be right 3. Opposite of what we think because there is an x minus h in the outline. Then at the end it's a plus 1. So that means we're going to go up 1. So to the right 3, up 1. Looking at this guy, x plus 2. So it changed to a plus instead of x minus, which means we're going to go left 2 because it's the opposite. And then we have a minus 4. It just swooped down. It's my quickness in making this worksheet. So that means it's going to go down 4 because k does exactly what you would expect it to do. Now our natural log, again, you're looking for h and k. H is a positive 5 because it's x minus h, so h is positive 5, which means we're going to go to the right 5. And then plus 3 means we're going to go up 3. Last but not least, our last exponential, so x plus 1, remember it's x minus h, so that means we actually went to the left 1 because it's a negative 1. And then minus 3 at the end means we went down 3. So again, transformations, translations, anything that you can write out. If it asks for transformations, it wants to know up, down, left, right. Did it flip over the x-axis? Did it flip over the y-axis? In this case, all of these stayed positive, so none of them made a flip, which is why this is translation in this table. It means just left, right, up, down, just slides, no flips, no stretches, and no compressions. Now, domain for all exponential functions, domain. So that would be all your x values. If I have a horizontal line asymptote, and that means you can look but you can't touch, so it's never going to touch this line at y horizontally, that's this way, that means the only parameter means there's going to be a roof or a floor on this graph. So that means left and right is going to go forever and ever and ever. So every time you have a horizontal asymptote, y equals, then your domain is going to be always all real numbers. So for all of our exponentials, domain is all real numbers. And that r with the double lines is just another way to write all real numbers, or negative infinity to positive infinity. Same idea, but the opposite, because now I have a log, which is a vertical asymptote, so x equals 3, means that there's going to be walls on this house, but no roof or ceiling, which means I can go up and down forever, and up and down is going to be our range, so our y values. So our range for all logs, so all logarithmic functions, the range is all real numbers. Or again, negative infinity to positive infinity, or our double line r. So all log functions have natural logs, all log functions has range of all real numbers. So the only thing you have to really think about is the opposites of those. And these parameters where you're set up your rules, your asymptotes, it's where they're going to count. So that means it's going to be from negative 2, depending on how you write it, to positive infinity. So y is going to be greater than, but it's going to be less than positive infinity. So it can be written in that form, or negative 2 to positive infinity. And that's just a notational difference. Up to you in what format, what teacher, all that fun stuff. But ideally, we're looking at our y for range always, and it's going to go from negative 2 because that's where our asymptote is, and it's going to go up to positive because it is a positive graph. And sometimes you want to put these in Desmos to really make sure which direction it's going, whether it's going to go up forever or whether it's going to go down forever, and all of that good fun stuff, because again, Desmos never goes away. Now, log function, we're looking at domains. So that means I definitely have an x, and we're going to have, I just normally always start there and go from there. So I know I have x equals 3. So that means if my asymptote is at 3, it's not going to get any smaller than 3, and it's going to go on forever in the other direction. So positive infinity, or again, 3 comma positive infinity. Same thing, just a notational difference. So like kind of like fonts on Windows, where there's Times New Roman versus Arial. All right, we have another exponential, so our all real number domain. So we have to find a range, which is going to be y. And the y is going to be 0. It is a positive function, so it's going to go to positive infinity. So 0 to positive infinity. Log is going to be domain that we have to work with because we have an x equals. So that means it's going to put a rule on that x. It's going to give it a wall to a house. So left or right, it's going to stop. And it is a positive function. So again, we're going to go 0 to positive infinity. Our range is all real numbers because there's no ceiling or floor to a log function. It can go up and down forever. Exponential function, domain is all real because there's no walls on our house. There's just a ceiling or a floor. So we're going to do y. It's a positive function, so it's going to be greater than 1 and go to positive infinity. Or again, 1 positive infinity. Positive infinity will always be parentheses because you can't stand on infinity. And then asymptotes, it doesn't count, so it's not going to be a boxed here, like that box parentheses, because it can't actually touch 1. 1 is the asymptote. So it'll look like it's going to touch visually if you were to graph it, but it does not. And then log again, so we're going to look at our domain, so that's our x. -2, it's a positive, so it's going to go to positive. If it was a negative function, that negative infinity will go over here, and -2 would be its top boundary. So looking at this guy, x equals 5. Again, we're going to do x. It's going to be positive 5. It's a positive function because of that a value in the front, so it's going to go to positive infinity. And then another exponential, so our domain is all the same, so we're going to go back to y again. And it is going to go from a -3 to a positive infinity because, again, this is another positive function. So we're going to be working in the positive direction no matter if it happens to be on the y-axis or on the x-axis. That was really fast. Hopefully that helps some guys. If you have more questions, please reach out and ask me.